Thanks, Bob, for taking some time and spending a little quality time with the Certified Commercial Property Inspectors Association.
Absolutely. I'm happy to be here.
So I guess we got to get started here with why don't you introduce yourself a little bit, because I know you'll do a much better job than I could ever do. Tell us a little bit about your background and why you're here today.
Okay. Well, I graduated from Arizona State University in 1984 in both architecture and in finance. And I worked my way through college doing concrete repairs. It was better than working in the bookstore. And so I eventually specialized in things that required a little bit more understanding, a little more complexity. That was kind of my competitive advantage in that world. And eventually that led me to foundation repairs. And so I eventually became an installer of helical and push piers. And then that led me to understanding how to diagnose foundation problems. And I started to realize that the foundation industry doesn't really do a very scientific job of diagnosing things. They send out salesmen with 100% commission. And so I modified my business, and I think I'm one of the few contractors in the country that actually did this, where we built an entire team of engineers that would diagnose these things. And they were separate from the rest of the company. They did the diagnosing. There was no influence, by salespeople or anything in the process. I sold both companies about 3 years ago and retired. And so one of the things that I tried to do is export my thinking to other contractors, and I was not successful. Nobody wanted to do it. It just was not something that it was too hard. It was, whatever, lots of excuses, right? They just didn't want to do it. So I just decided, you know what? I think I need to become an advocate for homeowners and help them understand the process, help them understand who they should call, and help them understand how not to be ripped off, because it's happening a lot. I call it the silent fleecing of America.
Excellent. So when you read in your bio, you call yourself the dirt whisperer.
Yeah.
Yeah. Where did that come about?
Well, a lot of these problems with foundations are, manifested through soil conditions. One of the things that everybody likes to do is they like to call a structural engineer to evaluate these problems, and that's really not the right person. They might come out and say, well, it's not structurally deficient, it's not going to fall down. And we're like, okay, we kind of knew that it wasn't going to do that. Is it going to get worse? Could it get bad? Yeah. Oh, yeah, it could if it continues to move. Well, is it going to continue to move? Well, you have to contact a geotechnical engineer. He'll have to tell you that, So you just wasted all your money with a structural engineer, because he can't really tell you if it's going to continue to move or not. And so I started to realize that early on and tried to understand the soils. And I came up with some very innovative solutions in the soil to solve problems. And so hence the nickname, the Dirt Whisperer, because I could get the soil to do what I wanted it to do.
What do you mean by that? How do you train soil?
Well, I've developed several patents over the years. I have about 10 patents. One of them is a moisture level system. And what that does is, it's kind of hard to explain it all real quickly here, but one of the problems with soil that people don't even realize is you have expansive soil heave. You have soil that gets moist over time and it swells, and it can swell up and it's very powerful force. It can break concrete, bend steel, cause just as many problems as settlement, maybe more. And so I developed and patented a system that dries the air under a foundation system called the moisture level system, that dries out those soils and stops them from heaving. And then I've developed a number of other patents. One of them is a needle pile system that raises an interior floor using a very small 2-inch diameter hole. And that solves a lot of problems in the industry. those are just a couple of examples of some of the things that I've done solving problems in soils.
It's interesting because a lot of our inspectors with the CCPIA are transition inspectors that might have come from residential, that graduated up into commercial, etc. And so a lot of this conversation has a pretty good translation, and I can think, Bob. I shudder to say the number, but I can think 40 years ago when I was starting my career down in Louisiana, all those houses were built on pilings.
Right.
You'd
Very
you'd
common
take
there.
you'd take that foundation, and let's say it's 750 or 850 square foot, and you might have 20 or 30 pilings pounded into the ground. One of our key metrics was a simple water survey.
Right.
Where
Water level.
water
Floor
level.
levels.
We'd walk around that house for an additional fee and take 30 or 40 plots and actually map that out. So that's kind of what you're talking about.
Well, as a matter of fact, I sort of pioneered the whole analysis of what you're talking about, a floor level survey. We've developed software that takes the data points. Well, first of all, we have an interface with an instrument called a smart level, invented and developed by Mike East. And it has a Bluetooth function. So, and we've built a software interface with it so that if you're walking around the house, you just press a button and it puts that elevation automatically into your drawing at that location. So there's no fumbling of getting the numbers and fat fingering it and getting it wrong, or getting it, 1 inch off accidentally, or, all those problems. I've done all those things. This eliminates all that, speeds it up quite a bit. And then it does a thing called a calculation called tilt and deflect. And that's a PTI calculation that basically tells you how severe the problem is. Because, that's what most people want to know, right? They want to know, okay, how bad is it? Is it really bad? And what that does is it calculates tilt and deflect based on the allowables from the Post-Tensioning Institute. It's basically L over 360, which is deflection, and 1% for tilt. And if you exceed either of those two, then you fail. So that gives you a nice metric that makes it objective as opposed to a subjective. So much in this industry is subjective and it's wrong. So I'll hear, a salesman, a foundation repair salesman say to, a customer, well, Mr. Jones, on a scale of 1 to 10, I think your foundation is about an 8.5. And I'm thinking, wait a minute. What is that? I've never heard of a 1 to 10 scale. Is that like the Richter scale of foundation repair? What is that? And then I think, okay, how did you arrive at 8.5? How did you get there? What metric did you use to get there? And they're like, well, based on my years of experience and the fact that my kids need braces, I arrived at 8.5. And it's subjective bullshit. And this eliminates that. And what's nice for inspectors, if they want to do these foundation inspections, is, they're trying to figure out, okay, I've noticed some cracks and I've noticed some problems, contact an expert. Well, who's an expert? A lot of times in commercial world, you get a little more time, but in the residential world, it's rush, right? And so then they're in a hurry and they can't get an engineer out there. So then they contact the foundation repair company, who sends out a salesman and says, oh, you need $80,000 in piers. Of course, then the whole thing falls apart. Everybody loses their commission. It's not a happy day for anybody, right? It's just not a good solution. It might be a problem or it might not be, but if you contact a foundation repair salesman, I guarantee you one thing, it's always going to be a problem. It's always going to be an expense, right? And so what this tool does is, if they use it, if they're trained and used it properly, is they can go out and do this floor elevation survey and then it automatically calculates tilt and deflection. So then the home inspector can say, well, here's the results. It's, it's not my opinion. It's what the data is, and the data says you pass, or the data says you fail. And then that helps the home inspector two ways. Number one, if it passes, end of the road, everything's good. Everybody goes their ways. It's a slight problem, but it's not a problem that needs to be addressed. If it is a big problem, okay, well then let's get an engineer involved and let's get him, because sometimes even if it fails, if it's done moving, it still might not be a problem, right? So let's get an engineer involved. Let's get him to provide a solution if we need one, because half the time you get a salesman out there and he might like say, okay, you need a bunch of piers that go down 30 feet on this side of the house. Half the time they don't even know what they're doing. They get it on the wrong side of the house, or they get too many, not enough. Maybe they don't need them at all. You get an engineer, and here's the other problem. You get 3 different contractors, you get 3 different solutions. Well, who's right?
Right.
Nobody knows, You get an engineer that says, okay, fix the drainage. That'll solve the problem. Or, okay, maybe you need some piers. Put 4 piers right here. Go get 3 bids for 4 piers. Now that becomes a lot easier process to manage. And it all starts with, how do you analyze it? You have the software that can calculate these things automatically and tell you where you need to go. And it's exactly what you were talking about with this floor level survey.
So is when I think about the inspection process, we always work in, or we try to work in the ideal: plumb, level, square, straight, because that's how buildings are built. And as you're walking around a building and you feel that unlevelness, or you see the floor is not straight, now that's immediately causing that attention. So in this analysis that you're providing, that can take and actually put a quantified number to it.
Exactly right.
And you no longer, and being I always say, I'm trying to eliminate bias, and the sales is bias.
Right.
It's numbers don't lie.
That's right.
So I think about this now, Bob. If I'm looking at this concrete and, again, in that squareness and the plumbness and the straightness, how do I actually know what's going on under the concrete?
Well, you probably don't, but that's why we have geotechnical engineers, because one of the myths of the foundation repair industry is that soil is a simple thing, and it's not. It's not a simple thing. It's deposited in layers, and each of those layers has different mineral content, different density, different affinities to water. The layers are not even. They disappear and come back and reappear at a lower level. And each of those layers is doing something simultaneously with water, because water is really the catalyst that causes a lot of the problems. Not all of them, but a lot of them. And water may be moving through these various levels and interacting with these layers. It usually moves between the layers because that's the easiest place for water to move. And so if you have all of that going on at the same time, some things happen, like for clay, water might hit it and it might expand. If you have silts and sands, water might hit it and it might contract, right? Or if you have clays that dry out, they might shrink. So there's a lot of things going on that needs to understand. And it's very hard for a layperson to figure this stuff out. It's really difficult. But that's why we have geotechnical engineers. They understand the geology of an area. They understand the depositional process that occurs. They they do borings in it all the time. They understand the layers. They understand how they react in a local area. You want a local guy. You don't want a guy from New York, telling you what to do in Texas. That's not going to work, right? But that information is super valuable, and those guys can then say, "Oh yeah, well, here's what I think's going on," and based on the information that's provided, one of the things that we do as a company is we provide a certification process for inspectors. And the reason that's important is because if they gather the data properly in a way that engineers and do the verifications, because engineers want verifications, right? They don't want to take people's word for things. Their license is kind of hanging in the balance, right? So, for instance, if they're saying that, okay, it's a truss system, okay, show me the timestamp pictures of the trusses, show me the plates, that kind of thing. If an inspector is trained and certified to give the data to an engineer in a way that he can verify and understand, then the engineer can grab that data and provide that analysis that you're talking about, so that you can avoid having the engineer go to the site, because that's very expensive. You're talking grand, for an engineer to go to the site. That's just not very palatable in today's environment. And on a commercial building, it's comparable depending on your square footage, but it's roughly 20-25 cents a square foot, right? An engineer is going to be quite a bit more than that. And if you can provide the data to him and he'll accept it, then you've saved the customer a ton of money and given them a lot of value.
So if I'm a commercial property inspector walking around a 35,000 square foot building, most of those buildings are on slab. In most places in the country, they're probably not in the size of the buildings we're thinking about, probably not a floating slab, probably a slab that's built on some form of footing and foundational wall with the concrete poured either floating on that or being supported. What advice would you have for that commercial inspector of how to look at that concrete?
Well, floor level surveys is the instrument of choice to start with. Okay. I wrote a book, and it's available. Well, I'm not sure it's quite available yet. We're still working on the publishing part of it, but it's done. And it's basically the 16 data points that need to be gathered for a performance evaluation for a foundation. And one of them is the floor level survey. That's one of 16. Another one is a damage map. So you want to take the floor plan and you want to write, okay, where's the damage in the walls? Where's the damage in the floors? Where's the damage in the ceilings? And make symbols on the floor plan. And then you can kind of overlay that with the floor levels, especially if you have a floor level that shows the topography. The Spatial Vision software basically converts all those numbers into a nice, easy to understand 3-dimensional topography that you can easily see. Okay, this part goes down, this part goes up, and now you can say, okay, well, the part that goes up is like, that's the same place as all these cracks, or the part that's down is the same place. Now you start to put 2 and 2 together. And there's other things that you can look at besides that, but those are 2 of 16 things that you could gather that will help understand, okay, now I start to understand, like, for instance, what's the soil like in the area? Are there clays? I mean, some areas don't have clays. So then that makes it much simpler. Yeah, lots of pieces of data like that gather and help you figure things out.
So I think about our standard of practice we call the ComSop, and what are the key tenets or pillars to it is we're not practicing engineering and we're not practicing architecture, and we have our walls, and that protects us. So when you talk about these 16 steps and you talk about these certification, how are we protecting ourselves from just data capture and not performing engineering analysis?
Well, that's a great question, and I think it's super important to address, because otherwise you end up getting down the rosy path here in the wrong place. So what we want to ensure is that inspectors are collecting data only. They are not providing analysis. Now, there's a little tweak to that. The software does give you tilt and deflect, pass or fail, but this is not an opinion of the inspector. This is just using the data to arrive at allowables for engineering standards. Now, some of these 16 points, the engineer gathers online, so it got nothing to do with the inspector. Probably maybe half of them have something to do with the inspector. So, for instance, you want to conduct an interview, if you can, with the property owner and ask them things like, how long has these problems been going on? When did they start? Did you have any plumbing leaks? Uh, Questions like that. These are things that the inspector can gather, and they can gather it and report it. And it's up to the engineer to figure out what it means. That's their job. Theoretically, I would prefer a geotechnical engineer. Some structural engineers that specialize in forensics know enough about soils; they can do a good job, but it's a little more difficult for them. But to your point, you don't want the inspectors opining about any of this stuff. It's not their area of expertise. And a lot of the inspectors that we work with work under the license of the engineer. So they're covered under the engineer's E&O. And all they're doing is gathering the data and providing it. That's all they're doing. We don't want inspectors opining about any of this stuff. It's not their lane.
I've always said that for the last 40 years, I've been a non-practicing, never educated structural engineer out looking at buildings. And so don't ask me those questions, but I'll tell you what I see.
Right.
I've taken and please correct me if I've been doing this wrong. My father was a structural engineer, and he built mostly bridges and highways, but he had given me a piece of advice decades ago where I can use a dead blow hammer on certain areas of let's say I saw deflection or lack of plumb or lack of level, and if I hit it with a dead blow hammer, I could sound the concrete to hear solid or tinny or hollowness, to give me some form of inkling that something's below. Because at the end of the day, Bob, my client might want to travel a forklift over that path that has a 10,000 pound spool of paper, and maybe the existing owner never drove a forklift over that area. And so this discovery, I mean, is that a correct analysis I was doing, or is that an analysis that is has some validity?
Depending on the situation, you could have some validity to it, and I'll explain that.
Yes,
so,
please.
First of all, soils move in a complicated way. You might heave up in some places, you might have some settlement in some areas, and the settlement might not have anything to do with the weight on it. It could be that there's a weakness in the soil 20 feet down, and 20 feet of overburdened soil is making that weakness settle, right? Which could leave a hollow spot under the slab. Or you could have the slab heave up, and then right next to it, you might have a hollow spot, right? So there's a lot of things that could cause these problems. And in a warehouse floor, what I've seen commonly, and I've done a lot of warehouse repair floor repairs over 40 years, what I see commonly is you have slab curling. So slab curling is when you have concrete that the aggregates might settle to the bottom of the slab during the placement process, right? And the top gets more fines. And so the top shrinks more than the bottom because there's more fines and less rocks. And so you get this curling up, this banana effect. And where it manifests itself quite commonly is in the joints where they meet. Mm-hmm. And all four of those corners will go up, and they'll go up maybe a half inch, maybe an inch, depending on how much curling you got going on. Well, that leaves a hollow spot under the slab, and you drive over that with the forklift, you're going to crack those four corners, and you'll see cracks diagonally in all four corners quite commonly. And is that a problem? Yeah, because it might not settle evenly, and now you got lips, and then the forklifts are driving over it and pounding and causing all kinds of problems. Well, so you can solve that problem by simply injecting a thin, runny grout underneath the slab, and then grind those high spots out, and you've solved the problem. So that's one way of solving that particular problem. You back?
It's interesting. Would that then show up, if you were looking at it in a broad sense? Did I lose my mic?
Well, you froze for a second, but I think you're good now.
Okay. Would that then show up as a broad sense across it, like maybe almost look like a washboard?
Well, I wouldn't really call it a washboard because, curling, might kind of go 20, 30 feet between high edges, right? Which is maybe a really large washboard, maybe, but nevertheless, it does present problems for the wheels because those wheels on forklifts are a lot of them are not pneumatic. A lot of them are hard rubber. So if there's any differences in the joints, it's going to pound the heck out of them. And pretty soon you're going to start having cracking and spalling and deterioration along that joint and lots of problems occurring. And, then they get bigger and then they, from there it just gets worse, right? So you want to avoid that process starting. That's the best place to be.
Well, and on top of that, you've got wear and tear on machinery.
Yeah, it'll tear the heck out of that machine. That's right.
Yeah, and if you're driving on it, you got the wear and tear on the machinery. Then you've got the wear and tear on the employee, and then you could potentially lose a load.
Yeah,
so,
right.
So there's a lot of combat. So what advice would you, if you were a commercial property inspector entering a commercial building, and you don't have access to the current ownership for a person of knowledge to even have an interview process. Yeah, and you're walking in there sight unseen, what sort of process would you undergo to take a look at the structural aspect of that building?
Well, bear in mind that my area of specialty is in slabs and foundations, right? So
that's what I want to look at. I'm not worried about the sidewall, not so much. I'm not worried about the steel or the trusses or the roof.
Right.
Looking at the slab and then that
Mhm.
intersection of the slab to the
Right.
wall.
Right. So first thing I'd be doing is looking for signs of wear and tear. And it's
Okay.
always going to show up as small cracks first before it starts deteriorating. So you want to look at those. You want to you want to do a floor level survey so you can see if you have issues with either curling or some other problem going on, maybe settlement or heave, right? That can all cause problems in the long run. I had a warehouse building. Oh man, brand new building built on top of a solid concrete landfill, and this building settled 15 and a half inches and was settling at the rate of a half an inch a month when I first came across it. And it was near collapse. I don't say that very often. Matter of fact, it's really one of the few buildings I've ever seen in my whole career where it was scary. It was not safe. And we raised it up. We raised it up 15 and a half inches. Took us 3 years, $6 million. And it's being used by Amazon today. Great building, no problems. Been 8, 9 years since the work was done. And but you can have big problems like that in some of these commercial buildings.
Yeah, because I've always had the inclination, Bob, that commercial buildings are built with so much closer oversight than, let's say, a residential.
Yep.
There's I don't want to say engineers, but I mean, there's certainly people on site during the entire construction overseeing, compacting if it's the soil, making sure that everything is just right, where in residential, it's kind of good luck.
Yep. Yeah, I agree. It doesn't mean there's not problems in commercial, but for the most part, it's built to a higher standard. You have better engineering analysis, you have better soil information, you have a little more detail going into the structural drawings, you have better inspections on site, the whole process, change orders and RFIs and the whole process that tends to get not dealt with in a proactive way on residential. Those builders are so damn cheap. They won't spend $300 to make a better foundation. If they're going to spend $300, that's going to be in cabinets where people can see it. It's like, okay, well, your foundation can go to hell. Well, it's going to be long after I'm gone. I don't care. That's just their attitude.
I had a house built one time and the builder completely omitted H-clips on the roof deck. And that saved him roughly $45. And at the end of the day, you could see every piece of plywood. We dumped the house. We weren't in that house 3 years and said, I just can't handle this. Type of thing. So you're right. So now you have a product called Spatial Vision. So is that the end product for your slab measurements?
That's correct. So that's the software that gathers the data, the elevations, and puts it into a 3D model that you can visualize, which is very helpful. It also calculates automatically the tilt and deflect that we talked about. And so it's very, very helpful in understanding the severity of a problem and making sure you understand kind of what's going on. I mean, ultimately, one of the things you want to do, almost all buildings, residential, commercial, whatever, none of them are built perfectly flat, right? It's not achievable. So what you want to do is you want to take that data and see with all the other factors what's going on. And one of them is time. So for instance, you might want to do an elevation survey and then 6 months or 12 months later, go and repeat it. And that way that gives you, and one of the things the software does is it automatically, when you get to the right function, will subtract the earlier data points from the current data points and develop a whole new model representation, 3D, that shows you how it moved during the intervening time. And that is super, super valuable because I've looked at, okay, this is the survey from 6 months ago, and this is the survey from now. I can see they're a little bit different, but I can't really see a pattern. It doesn't, there's nothing that goes into my head that says I understand what's happening. But as soon as you put that subtractive topo on there and you can see how it moved in the intervening time, whammo, it becomes crystal clear automatically. Oh, well, this side went down over that time and this side went up and this side's got damage and this side doesn't have damage. And then you can start putting together all the things. This side has sunshine on it. This side doesn't, this side has trees, you start putting all that stuff together. But that data over time is super, super valuable, super valuable.
It's almost like the advent, Bob, of that grid pattern overlay you can do on a sidewalk crack, where you'll see somebody epoxy that to the wall so they can see over time if specifically on that, if this crack is moved or not moved.
Yeah. A crack gauge.
Yes.
Great tool. I highly recommend those in cases where you suspect you have movement going on. Then you can start to realize, then you can do a damage map that's similar to what we talked about with the subtractive topo. You can say, okay, over 6 months, these cracks got bigger. These cracks didn't. And how does that compare with what the floor level shows, And then you start putting 2 and 2 together and you've got real-time data of what's happening currently. And now you can start to not you, but maybe the engineer can start saying things like, okay, well, it's moving or it's not moving, or this part's moving and that part's not moving. This needs to be addressed. Maybe we fix the drainage over here, lots of things like that.
So many inspectors are entering the commercial world and they look at it in a different mindset, obviously, than residential, where we've got a more educated client, a client that's more proactive to their building. And you said something that's very interesting to me that I want to go back to, and that's I did my analysis today, but I'm going to come back 6 months from now, and I might come back another 6 months. This becomes, in the eyes of the inspector, residual work.
For sure.
It, uh,
We,
if
we used
I
to do that all
was,
the time with commercial customers, and they would come back every
and
year.
I
They would
love
hire us.
that.
Yeah.
Because that makes my company valuable, because I've got jobs on the books, reached out. So if I know the question is going to come up. It's a 35,000 square foot rectangle. How, and let's say it's modestly occupied, so there's stuff in the way, but it's not vacant. How much time should I allot if I'm proficient with the equipment, to gather the data on my first visit?
Well, part of it depends on what your equipment is. And a lot of people like to use a zip level, and I've used zip levels over time. It uses a gas inside the tube, and that creates problems with calibration and inaccuracy. And I've used a water level for many years, and that's much more accurate. But if you're transferring all those numbers by hand, it's going to take you a long time. So if you have a smart level that has the Bluetooth enablement on it, and it hooks up to Spatial Vision, now you basically cut your time in half, which is super valuable for inspectors, right? If
Right.
you can spend 4 hours as opposed to 8 hours gathering up all that data, that's valuable. So part of that is what equipment you have.
Well,
And I wish
let's say I invest in the best equipment. I'm going to invest in the exact equipment you're ascribing.
Right. So I was just going to comment that it's been a while since I've done one of these. My head trainer, Zach Lassiter, probably could answer that question really super accurately. But I would guess, let me think about this. You can do about 2,500 square feet in about on a floor level survey in about an hour. Maybe a little less. So you can extrapolate that out. Maybe so if you have 3,500 square feet, that's 11 times that. Now you might be able to go a little faster because, for instance, if you have a large warehouse floor, you might not have to take your points, 7 feet on center. You might, if it's a large area and there's not much going on with it, maybe some areas you might want to do 10 feet on center. And that might speed you up a little bit. So you can kind of help yourself, based on your judgment of what's going on, to kind of help yourself a little bit. But I would say, roughly speaking, 45 minutes or so for to an hour for 2,500 square feet.
Okay. So you're going to add probably a day to your project.
Yeah, big project. That's right.
Yeah, which is fine. It's more expectational, right? So if I'm talking to my client and I've become an expert at this analysis, or at least this gathering, because this is a direct concern of theirs, then I need to have that expectation moving forward of what is going to be my effort. So when I job cost this out and need to assign a fee to my client, I can do this without taking a bath, and understanding it. So I love that. Um, what I've always liked on commercial is, especially that you look at this large slab, there's usually control joints cut. Whether they're on a 10, a 15, a 20-foot grid pattern, boy, I don't even have to measure. There's a point, there's a point, there's a point, and I can just keep chugging through this building in a very logical manner and not miss something.
Right. Absolutely.
And if you're going to do this right, then I would think, Bob, if I'm going to come back in 6 months, I want to use the same data points.
Oh yeah, for sure. And you want to use the same drawing, which saves you a lot of time because now you don't have to redraw it. Now, hopefully, maybe the client can provide drawings, But
Yep.
if they can't, you're going to have to draw it. And second time around, you don't have to worry about that. You've already got it done, right?
Yep. And then you might come back another 6 months, and there are some buildings that want a very proactive nature because that building is an asset. And there's other owners that just leave the building alone. It is what it is.
Well, depending on the situation, like for instance, if your building is in a known area with clays can be cyclical. You go through a dry season, they shrink. You go through a wet season, they expand, right? So you might want to take measurements in the wet season. You might want to take measurements in the dry season. You want to maybe know what that difference is, right? And the owner may want to know, okay, how's this reacting to the various cycles, especially if you're in a place like Texas where there's really expansive soils and a lot of problems, right? Texas has a lot of variation in moisture. They may go a long time without rain, and then all of a sudden they'll have a deluge, right? And so that creates problems in expansive soils. There's other parts of the country that have similar problems, but Texas is a really good example of that. So
Yeah.
you
I
might
mean,
want
I think
to measure those variations to see how it reacts to those.
I think where you're located in Arizona, our daughter's in Tucson, and they have monsoon season.
Yeah,
So I could only imagine that I get rain, but I get my foot of rain in 1 month.
yeah.
Of what?
Well, in Phoenix we get 8 inches a year, and probably 6 of that is in the monsoon.
Yeah, and it's happened. It's going to happen right now. Here you go. And so you just wonder what that does to a what you wonder why that does what it does to a building. I can appreciate that. What type of so if I'm a commercial property inspector, I'm in. I'm wrapped around this. I'm going to start doing this data capture. I'm going to reach out. I'm going to get trained. I'm going to use spatial vision. Which industries as a client do you think would most greatly benefit by this type of analysis, or does it not meet the industry? It's the building.
It's probably more the building. I mean, I think warehouse floors, they're somewhat sensitive, more sensitive to these problems, right? And so they're gonna pay more attention because of all the things that we've mentioned earlier. Uh, but for instance, large shopping centers, if you've got 55,000 square feet and you got a lot of movement and you have freezers and other things like that do things to the soil, uh, and you start, and you're on some sensitive soil, you might want to keep track of that. You might want to, be careful of, future movement and try to mitigate it, try to understand it, all those kinds of things.
Yeah, I just think when you start talking, and my mind just goes completely all over the place. And I start thinking about shopping centers, then I start thinking about pedestrian hazards and trip hazards, and maybe a piece like you talked about heaving. Now that racks a section of tile. Now all of a sudden I'm going to knock out a corridor of a building, which then knocks out, the 7 stores that are in that area that now I can't get patrons to go to. So it just this whole cycle just comes about by identifying plumb level square straight and having the tools and the training to move the chips forward to a new conversation.
Yeah, and do it in an objective way, right?
Yeah, yeah, yeah. We're not selling anything.
Right.
We're absolutely the only thing we're selling is knowledge.
That's right. Data. Data is the new oil, right?
Yep, yep. I love that. So what haven't we talked about, Bob?
Well, let me think about this. There's lots of myths in the industry. We've discussed a few. Do you
Yes.
have any that questions or myths that maybe you've heard and you're not sure uh, if you agree with them or understand them? I'm trying to think of a few off the top of my
My
head.
biggest thing that I have is like I said, I've done a lot of I call it ultrasounding. a lot of dead blow hammering on slabs, and I do so more frequently around where roof drains are exiting into a slab
Right.
because of some form of offset that might happen in that pipe from soil movement,
Yep.
collapse,
Yep.
all those other things. And that's where it's not necessarily a pronounced structural problem because our structure is not in the slab, but it certainly becomes a material problem that I can identify for my clients.
For sure.
Um,
And mitigate performance with it. That's
yeah,
exactly right. Performance
yeah,
problems. Yeah.
I might be between clients, and this client was a woodworking shop, and now this client's a print shop. One's going to have two different levels of weight placed on that slab, and so I'm taking away from our call today, Bob, is I've got such a new opportunity to slab survey using spatial vision the foundation of a foundation or the slab portion of a building, then I can project this forward to my clients and not only a today knowledge, but a new business line.
Let me ask you, if you have to draw the building, what software do you use to draw in?
I'm using a pen and paper and scanning it. I'm old
Okay.
school.
All
I'm
right.
old school. I'm going to use pen and ink.
And that will work with spatial vision. But one of the things that we're working on with the manufacturer of the smart level is uh, a drawing interface. So if you use any kind of a CAD, Junior CAD, AutoCAD, whatever, it will recognize that and import information right into it automatically, which saves a ton of time.
Yes, it does. I
So
mean,
that's another maybe time saving tip that you might think about.
yeah, if I was doing this, I'd probably grab a satellite image of the building. I'd make a pen and ink outline of the building, and I'd pull that off, and I'd say, "Here's my footprint," because I don't care about walls. I don't care about partitions. I just want the footprint.
Yeah, sometimes walls can be helpful, and I'll tell you why. Sometimes, like if you have plumbing, you want to know, okay, here's the kitchen, here's a bathroom. Plumbing trenches conduct moisture. So
Yes.
there are going to be avenues where the moisture can enter the building from the exterior, and simultaneously, those areas don't get compacted very well. They're always afraid of breaking the lines, right? So it's helpful to know where those are in a building because it helps to understand. Okay, here's a problem in the kitchen. Uh, so those kinds of things. Even commercial buildings. They all have kitchens, right? I mean, it's just the
Yep.
way it is. They all have bathrooms. So it's important to understand where the water's. Here's the drains. A lot of them have little drains, right? How do they work? Drains leak a lot more than intake pressure lines, right? So again, I mean, one of the things you want to maybe advise your client is, okay, let's get a, a static uh, plumbing test on all of your drains to make sure we don't have leaking anywhere. If you're seeing problems, and you're like, I don't understand these problems, well, the engineer's thinking, this doesn't make any sense. Well, okay, let's go get uh, some analysis by a locator, not a plumber, a locator. So that we understand, all these drains, are they all functioning properly? Do any of them have leaks? And that helps understand the problem. And now and so your drawing helps understand all that stuff. And if I was in your shoes, I'd want to put the location of each of these drains so that we could reasonably understand. No, you can't know for sure unless you provide a really expensive locating
As no.
service for every one.
Yeah.
But you have a
Well,
reason.
what's interesting though, Bob, is most of our inspectors all do sewer scopes as
Sewer
as
scope
part
can
of their
help.
an offering, and many sewer scope cameras come with locators, and
Right.
so
So that would
they
help.
could, in conjunction with, I mean,
That
they
helps.
could they could add an enhanced service
For
to their
sure.
clients
For sure.
that
However,
goes,
let me give you one caveat.
yeah,
That may be very, very helpful. But over the years, I've done a lot of this, and I've seen hairline cracks that you cannot see in a scope. And you do a static test, you will discover them. So maybe the scope will provide good initial analysis, but maybe sometimes to locate difficult situations, you're going to have to do some static testing.
sure. I appreciate that. So I'm going to make sure that at the end of this, we're going to put on your contacts, because I think spatial vision is really a neat opportunity for commercial property inspectors, Bob. Do you have any other questions that you want to ask me?
No. I mean, I think we covered a lot of ground, and I think you're super knowledgeable and far more than a lot of inspectors that I've talked to. And so I think you're headed in the right direction, and I think your audience will benefit from that.
Thank you, Bob. Thank you again for taking some time and being with us here and building your business. And I look forward to seeing how this expands the future of commercial property inspections.
Absolutely, it would be awesome. And by the way, if you need to find an engineer, you can go to my website, foundationrepairsecrets.com, and there's a directory and by state of
Excellent.
every engineer that offers these services. Now, some of these I've vetted and some of them I haven't. I probably should get busy and finish vetting a lot of these, but I've at least found them, located them, seen that they offer these services and so forth. So if you don't have anybody in your area that you know to work with, pull onto that site. It's free. I don't take money from any of these guys, so it's conflict free. Go find them, and hopefully, and by the way, if you find a good one, send them to me. I'll add them. It's easy, right? Because I'm just always trying to help people get in touch with the people who are going to give them the most value.
And so are we, Bob. So are we. Thank you so much.
You bet. You're welcome. Glad to be here.